Welcome back to the channel. Hope everybody's doing well, and in today's video we are taking a look at this clamp meter from Chauvin Arnoux. Chauvin Arnoux do have their own YouTube channel. I did ask them on there, gave them a spec of what I wanted for a clamp meter and which one they recommended. They actually recommended the series below this particular one, but they said this one here, which is the F407, is the most popular clamp meter that they sell. So I decided to opt for that one to see how I get on with it. So this F407 is actually a harmonic clamp meter. This one is brand new to me, come boxed. Currently on the UK market it's retailing for around about £600, all tax included. Inside the box itself you get a meter in a bag, and we get a load of literature. We do get a couple of CD-ROMs there, because this is a Bluetooth enabled meter, so we get a transfer software on this CD-ROM. We also get the manual. I know the manual is downloadable. I haven't found that yet. The transfer software, I haven't found it that to see if it's downloaded. I'm sure it must be. I'm sure it's me that's missed it. But nowadays I don't have a computer with CD-ROMs in it. So Chauvin Arnoux, it's one of their more upmarket meters. They're a little bit behind the times really with that, I would say. So put them to one side. The rest of the literature, we have a host of just a basic instruction sheet. They call it a start guide. There's just a bit of safety information on there, precautions for use, and the basic functionality of the instrument. That's all you're getting on that. You get it in multiple languages. The English one there, another one, Polish one. I think that could be Czechoslovakia, Romania, French, German, Netherlands, Spain. Actually, I presume that one's a Russian one then, on one I didn't quite understand. So a fair few languages covered off in those instruction sheets there. You then get some basic safety sheets. These are for the test leads. All multiple languages on the same sheet for each one of those. We get, I'm not sure why this is included really, just appears to be a confirmation of the meteorological check. They recommend a 1-year calibration. And then you get certificate of conformity, that's with nowadays on the CE marking, and you do get a wee little calibration certificate. This isn't dated, so you don't know when it was actually calibrated, other than that it would appear to be tested by Julia. But we've got set values in there, nominal and results, pass or fail. Obviously they are all passed, so a fairly comprehensive test there. The instrument, and so that's that. And then we look at the instrument itself. This is 2 compartments, fairly nice quality case. See, emblazoned with the Chauvin Arnoux logo. Inside here we've got a separate compartment for the leads. So you get a set of leads from Chauvin Arnoux. You've got their standard probes, which are very good for getting into terminals. Nice narrow probe on those ones. All standard 4mm of course, and the red and black. So these are silicon, feels like silicon insulated piece leads there. So you can store them in a separate little compartment. And then inside here we have a red and black crop clip, because they don't seem to fit in there along with the leads. Quite sizable ones. These are standard ones from Chauvin Arnoux, and they are quite sizable, which does have its advantages. So you do get a full set of leads and crop clips. When you get the meter itself, you've got a compartment in here for a little sleeve to put the meter in to hold that, and then you do have another compartment here for all your instruction manuals, should you want to keep that in there. But I did find that a little bit tight and a bit annoying to remove. That's why they've all been removed on my one. But yeah, fairly nice bag, reasonably well padded. And here we have the meter itself. Fairly set of easy ranges. We've got our volts, AC and DC on there. Can read from 200 millivolts way up to 1000 volts both AC and DC, both at 1% plus 3 digits. You do have a ripple on there as well, interestingly enough. Don't often see that on an instrument, not as a main function anyway. So it does measure the ripple just automatically within that. And then we move on to our ohms and continuity. Ohms, we're up to 100 kilo ohms for that one there. I'm not sure what the continuity level is, we'll look at that when we start testing. Amps, AC and DC. So this is split. We can measure up to 1000 amps AC, 1% plus 3 digits, or 1500 amps DC, again at 1% plus 3 digits. And we have our ripple on there as well. And with regard to current, we do have maximum peak and an inrush facility as well. And then finally we move on to our watts, and we can measure from 5 VA all the way up to 1000 kVA at 2% plus 3, but it will go up to 1500 kVA on DC, again at 2% plus 3 digits. And we've got our usual bits and pieces to work our way through on the screen. Let's put the we've got a backlight. There we go, there's the backlight there, nice blue colour. And then on our watch screen we can pace through from single phase, AC and DC, AC plus DC, and then we must have to hold it in for 3 phase then, I guess. And go back to AC. Yeah, so we get 3 phase, so I was on DC before, that's why I didn't respond. You have to hold it down to switch between single phase and 3 phase, and we get our watts of R and our VA on the actual display there. So that's our main functionality of the meter there. We'll set up with our SMRT again, and we'll make some measurements on it and see how well we get on with it. We are set up on a single turn clamp table. This actual clamp size here is quite large. It's 70 mil in height and 50 mil across, the size of conductor that it would take. So we're set to AC. I'm going to inject 20 amps and we'll just move the clamp around and just see how much variance we get on the reading. If I can zoom in a little bit, we are reading 20.17 amps at this moment in time. And we'll go I can't go all the way up to the top because without going to the side like that anyway. And then we've got 20.44. All the way, let's go central again just to make sure. 20.15, all the way down. So we can just see it on the camera, that's 20.09 there. Go back up to the centre. And we'll go across to the left. 19.91. And then across to the right there. 20.34, so a little bit of variance there. We'll put that into the computer and just see how that comes about. Okay, so we'll just convert everything to DC reading as well. We'll zero it. Zero there. DC amps is down on the bottom here. So we'll do the same test again. We're reading 20.2, bouncing around a little bit on DC. 20.24. Okay, we'll go up and we go to the side again. 20.58. Okay, probably going to go off screen now, unfortunately. We are 20.34 down at the bottom there. Let's go off to there. 20.05. Ooh, that's quite a drop. 20.049, yes, quite a bit of movement on the sideways. That's 20.32. Okay, put them into the computer and see what it comes out like. Put this little table up here showing the results of the positional tests. You can see that a couple of them are just ever so slightly out, marked up in red there. They're not out by much, but it does show you that position of the conductor in the clamp can affect the reading that you are getting, so it is worth paying attention. We'll move on to the inrush measurement function here, because that's quite an interesting function. Just before we turn the instrument on, the inrush function does have a threshold trigger to it, and to get to that you actually have to hold down the maximum peak button once you turn the instrument on and turn it around to the amps. Wait for it to beep. There you go, and there you see inrush. Zoom in there, hopefully. See it's flashing away there, 50%. This is a bunch of fixed options that you page through using the yellow button up here. Get to 70%, 100%, 150, 200, and then round to 5, 10, and then we're back up to 50 again. So that percentage value that you're seeing there is an increase on the current that the instrument is reading. So if your instrument is reading at 100 amps, the threshold would then be set to 150 amps. So it does work slightly differently to the usual inrush function you see on these clamp meters. Just turn it back to one of the ranges and step back up onto the amps. So to get to the inrush function itself, you select either AC or DC amps depending on which you want. I want to go to AC, and then we hold down the inrush function until AC flashes away. It's trying to detect what the current is now. Because everything's switched off and it doesn't see any current, it's actually settled on a 10 amp setting for the trigger level. That's the lowest it can actually be, which is your 10% of your 100 amp range that you see there. So we have our little program set up on our injection test set. This gives me a current for 100 milliseconds and it should be 300 amps inrush measurement. So we'll give that a little run. And you see we've picked up 297 amps this time. So that's the basic functionality there. What I'm just going to do is show you this trigger level and the way it changes. But what I'm just going to do is turn the test set on first and give a 1 amp injection, which this will see as 50 amps, and with my 50% setting that should actually then go to a trigger level of 75 amps. So let's switch the test set on. There's inrush, it's detecting the current. You see we've got 74 amps trigger level now, and then it will step up. It's picked up 291 amps inrush on this occasion. So that's the functionality there. Slightly unusual, I've not seen that kind of trigger level on an inrush function before, but there you go, that's what Chauvin Arnoux have decided. So we've seen it work in AC okay. What we also have is a DC inrush capability as well on this instrument, which again is quite unusual. Usually when I press the inrush button, when we switch to DC, which we do with the yellow button here, AC, DC, go to DC there. When I'd hold down the inrush button, it would just beep at you and there's no dice, it won't switch to inrush. Whereas on this instrument, it will follow exactly the same procedure. I'm going to leave the current switched off, so it should select the minimum trigger level, which we'll see is slightly different on DC. So it seems 15 amps. Now, as far as I know, the AC and DC ranges are 100 amps, so that should be 10 amps as well, but for some reason it's 15 amps. We will just go to run our program. We'll set to 300 amps inrush current again. I've got 297 on that one. It could be a little bit, yeah, I think the clamp might be a little bit out of position. That's why I'm slightly different to when I did the tests. So I'll just put up the table here of the results that I obtained. Because we have a minimum 10 amp on AC and 15 amps on DC trigger levels, I couldn't do the bottom values that I usually use with the rest of the instruments, but we got the top range values in no problems whatsoever. They're reading fractionally low. However, with our inrush function, we do have a 5% plus 5 counts accuracy on it, and since we don't display any decimal points, it's just a 1 amp minimum resolution. That gives you quite a big tolerance to be with inside. But this is the rest of the results compared to the other instruments that I've tested in the past, and you can see AC and DC, it's reading perfectly well, obviously aimed more at the higher currents than what I've been previously testing, but yeah, it's an interesting function that Chauvin Arnoux have put onto the instrument there. Not usually see trigger levels and DC inrush measurement on a clamp meter before. So we'll just finish this off with a little quick demo of the power functionality here. We are injecting 10 kilowatts should be, and we are reading 9.9 kilowatts or 9,900 watts there, so a little bit down, a little bit of reactive power in there. But our VA is matching our watts. With the arrow key here, you can move between the two displays to get power factor up, which is obviously 0.99. I'll just change the screen to give me minus 30, so that should give me a power factor of 0.86, which is good. Obviously our power has now dropped down to around about 8,600 watts. Our reactive power has come up now, but our VA has stayed the same there. So that's the power functionality. We can also do this with DC as well, which is exactly the same. We change our yellow button here to select DC power, and then we've got our 10 kilowatts there. kVA matching the same. Not sure why we have power factor on our DC there. Yeah, don't know it's there, but doesn't really mean an awful lot with that one. I can't change the phase angle on DC anyway, so yeah. But yeah, that's our power factor. Yeah, that's the power measurements that are available on the instrument. What I'm going to do to keep this video short is to move all the calibration measurements of the other functions into another video. So that'll be it for this one. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next video.